here is an example. Given a set of all items, a database transaction with some, you have to find all the transactions with all the rules X implies Y with minimum support S and minimum confidence C. So as you seen example here, 30% is a small, it's not like 80-90%. Confidence is a high, 80%. So if, for example, a frequent item set which is supports a minimum support, chicken, clothes, mail, but then within that, if you see that different association rules are possible. Clothes implying milk and chicken, or clothes and chicken implying milk. So in first case, confidence is 100%. In second case, also confidence is 100%. But we can do similarly different other combinations of such item set. So what's a frequent item set? The one which satisfies minimum support. Then we go with identifying association rules which are satisfying the condition of minimum confidence. So what we have in this is a remarkable algorithm which is basically discovered by a very famous data mining researcher, I think Nagesh Agarwal, University of Wisconsin. Now he's with Microsoft Research. He discovered this algorithm called Apriori algorithm. Apriori algorithm makes a very interesting property analysis, which is, it says that if you have a frequent item set which satisfies minimum support, then the subset of it is also a frequent item set. What does it mean? Bring it back to the discussion we had a bit earlier about limiting it to a size, k item set, right? If you have a k item set, if you dissect it, create a subset of it, the k minus 1, that also is a frequent item set for size k minus 1. So that property is very, very useful in order for us to go through the millions of transactions and filter out only those item set which are of relevance for you. That is why the first stage of finding out the relevant association rules given a prior value of support and a prior value of confidence is basically to get through that subset of the item sets which are satisfying this criteria, and that's where you get your first step, which is frequent item set identification. So in fact, one thing you can do after today's lecture, you can go through frequent item set mining. There are several algorithms which have been later proposed to improve upon a priori algorithm. But a priori algorithm is very simple. It takes into account the nature of the fact that every subset of a frequent item set, k item set, is also a frequent items. That's what we do. So then what we do is we do it the discovery of association rules in two parts. First, we find out all item sets that have minimum support. That's a frequent item set using the a priori property. Second stage is where we go and from the generated item sets, you try to create different combinations of rules and see which of them satisfy the minimum confidence. So this is a two-stage approach. So let me look at a priori algorithm first part, which is about identifying the k set. It's a very simple thing. Don't get worried about this algorithm. It's very simple. It states very simple that start from singular set, look at the ones which satisfy minimum support. Then at each stage, add incremental element by size 1, but then you check for the support at each level. So if you have done k equal to 1 and you increased one element, look at size k equal to 2. Then see that all of them go into minimum support and eliminate any of the additional sets generated by addition of one more element which does not satisfy the minimum support criteria. We are following this because we have to ensure that every subset of a frequent item set we discover is also a frequent item set. So in order to do that, we cannot take a risk saying that a subset is an item set, but if you have frequent item set, we have expanded it. The expanded one need not be a one which satisfies the minimum support condition, because at each k level, whatever your subset you're discovering, any k array subset of k, any less than k minus one, k minus two, each of them should be frequent item set at that level. That's the property. So this is a very intuitive approach. Start incrementally with size equal to 1. Look at all the combinations which satisfy minimum support. For to that set, you add one element, which are the corresponding combinations which exist in the transaction database. Then you look at minimum support and then eliminate those which do not support. That's where you end up with ultimately, if you have you wanted k item set, and when your k is reached, you will end up with those set of transactions with which have k frequency but which do not have any issue with not satisfying